When we are given a sequence, how do we find a formula for its nth partial sum? In this video, I'll show you guys 5 examples, and we also see if the nth partial sum, namely Sn, converges or not. So here's the first one. We have 1, 5, 9, 13, 17, so on, so on, so on. If you take a look right here real quick, we'll notice that this right here is just an arithmetic sequence because every time we're just adding 4 to it. So if you want to come with a formula for an, this right here is just going to be 4n. Remember the common difference is the coefficient of n, and n starts with 1. So when you put 1 right here, 4 times 1 is 4, and we will have to get to 1, so that means we will have to minus 3. So this is the an formula. And now let's take a look at the nth partial sum. I will do this the long way first. There's actually an easier way when we are going to add up the terms from an arithmetic sequence, but that will be for later on. Anyway, the idea of the nth partial sum is that S1, this right here is just the first term, which is 1, and then S2, this right here is just the first 2 terms, you add them up, so 1 plus 5, that will be 6, and of course you just keep on going. S3, this means we do 1 plus 5 plus 9, and that will be 15, and then just continue. So S4, this right here is going to be 1 plus 5 plus 9 plus 13, and we get 28, and so on, so on, so on. Perhaps let's put down one more. S5, this is 1 plus 5 plus 9 plus 13 plus 17. And of course, you can just do this plus that, which is going to be 45. And the idea of the nth partial sum is we want to find a formula for Sn, and that is a formula for these numbers. So how do we do it? We'll have a look. If you go from 1 to 6, we add 5, and then if you go from here to here, we add 9, and we add 13, and we add 17. Right? In fact, you can see that right here earlier. The numbers that we're adding every time is different, but if you look at the difference of the difference, you see every time we're just adding 4. So what does this tell you? You see that the second level difference, the difference of the difference, is the same. So this tells us that the formula for these numbers is going to be a quadratic. We will have a quadratic sequence, right? And in fact, you can just refer to a previous video where I showed you guys how to set up the quadratic sequence general form, and then you can use maybe the first 3 terms and then figure that out. And also you can use the 4 to tell you the a value. I'm not going to do that. You can use that though, but I will actually show you guys something else. Here, whenever we have an arithmetic sequence, and that's an important part, whenever we have an arithmetic sequence, in fact, to get Sn, you can just do the following. This right here, it's just going to be n over 2 times a1, which is the first term, and then we will add it with an, which is the nth term. And this right here is the nth partial sum formula for an arithmetic sequence. So let me just write that down right here for you guys, only for arithmetic sequence. And I will do another video to prove this formula for you guys, but here let's just use that. We see Sn is just going to be n over 2 times a1 is the first term, which is 1, and then we add an, which is that, for minus 3. And then from here we can just simplify, right? So we get 4n minus 2 inside, and we can factor out 2, so we get 2 in the front, and then this n, and then we have the 2n minus 1, and all divided by 2. And for this, we can see that the 2 and 2 cancel and distribute the n. So in the end, we can see that Sn is just going to be 2n squared minus n. So this right here is the formula for the Sn. Alright, so that's pretty much it. And now, the other part is that, does Sn converge? Remember, whenever we're trying to find out if a sequence, this is technically a sequence now because Sn, we're looking at these numbers, we want to see how it behaves as n goes to infinity. So all we have to do is just go ahead and check the limit as n goes to infinity of this, which is Sn, and of course we just have to do that, which is the limit as n goes to infinity of 2n squared minus n But guess what? When n goes to infinity, this is going to be so much bigger than that. Even though you get infinity minus infinity, but this is way bigger than that. So in fact, you just get infinity. And of course, you can imagine, the more you add, the bigger it gets, right? So Sn goes to infinity. So does Sn converge? I will tell you, no. In fact, Sn diverges. So this right here is it. So for number 2, we have 1, negative 1, 1, negative 1, 1, negative 1, so on, so on, so on. Let's find a formula for this first. Well, we want to start with positive 1 and it alternates the sign, right? So all we have to do is negative 1 raised to the n minus 1 power. That's it. Remember, n starts with 1. And you can also put down n plus 1 right here. That's fine. It will give you this sequence right here as well. Okay, n's partial sum. Here we go. S1 is just going to be the first term, which is just 1. Done. Next, S2. This right here means we do this plus that. So 1 plus negative 1 is just 1 minus 1, and that's equal to 0. Next, we have S3, and that's going to be 1 minus 1 plus 1, and that will be 1. And then just keep on going. S4, this right here is going to be 1 minus 1 plus 1 minus 1, and that will be 0. And then one more. S5, this right here is just going to be 1 minus 1 plus 1 minus 1 plus 1, and that's going to be 1, and so on, so on, so on. So here's the question. What is the formula for Sn? Meaning that we have to find a formula for 1, 0, 1, 0, 1, so on, so on, so on. To find a formula for this, you can use sine cosine, but because we used this right here earlier, so I will stick with this part. Check this out right here though. If we have negative 1 raised to the n minus 1 power, this right here produces 1, negative 1, 1, negative 1, and so on, so on, so on, right? And you see, if we have a constant sequence 1, this right here is just always equal to 1. This is very nice. Why? Because that's add them up. This way you can see this plus that. Let me put down the 1 first. 1 plus negative 1 raised to the n minus 1 power. This will just give us 2, 0, 2, 0, and so on, so on, so on. But we don't want 2, 0, 2, 0. We want 1, 0, 1, 0, and so on, right? It's okay. Just divide this by 2. Divide everybody by 2, right? So we can take Sn to be that. So we have 1 plus parentheses negative 1 raised to the n minus 1 power, and we divide it by 2. So this right here is a formula for the nth partial sum. Okay, now the question is, does that converge? Does Sn converge? So that means we will have to take the limit of Sn. So we check the limit as n goes to infinity of Sn, and this right here means we will have to check the limit as n goes to infinity of that formula, which is 1 plus negative 1 raised to the n minus 1 power all over 2. But if you look at the numbers right here, 1, 0, 1, 0, it's just up and down all the time. So in fact, this right here does not exist, right? There's no limit for this. Therefore, for this question right here, it will be no. Sn diverges. Alright, that will do it. Okay, for number 3, we have 1 over 3, 1 over 9, 1 over 27, 1 over 81, 1 over 243, so on, so on, so on. This is actually just geometric, right? Multiply 1/3 each every time. And the formula for this is just 1 over 3 raised to the nth power. Because n starts with 1, so if you look at this right here will work. Now, let's find the nth partial sum the traditional way. And I'll also show you guys the quick way to do that. Alright. Okay, dot dot dot. What's the formula for Sn? Like what we said earlier, right? If we have S5, this right here is 3 to the 5th power. So on the bottom, we will just have 3 to the nth power. On the top, what we can do is look at the bottom, minus 1 first. So I'm going to do 3 to the n, and then I'm going to minus 1. And then I will have to divide it by 2, right? So I will just take half of that. That's what we have. And now I'm going to simplify this a little bit. I will first put down the 1 over 2, and then I will do 3 to the n over 3 to the n. So let me put that down real quick. And then minus 1 over that. So 1 over 3 to the n. And as you can see, this is just going to be 1. And then this is just going to be minus 1 over 3, and then raised to the nth power. But we have the denominator 2 right here. So this right here will be a formula for the Sn. Now, what's a quick way to do this? This only works for geometric sequence when you add them up, alright? So I will write this down for you guys. Sn is actually equal to A1 times 1 minus r raised to the nth power, and then divided by 1 minus r. And again, this is only for geometric series, alright? So when you add them up, then that's the idea. Okay, A1 is 1/3, so let's put that down. And then multiply by 1. And then this right here is also 1 over 3 for the common ratio. And then we have to raise that to the nth power over, right here we have 1 minus 1 over 3. So again, the common ratio is 1/3. The first term is also 1/3. And that will be the setup. Is this equal to that? Yes, it is. That's why I purposely put this down like this. Now, we can see this is just going to be 1 over 3 times 1 minus 1 over 3 to the nth power over, that's just 2 over 3. By the moment that we multiply the top and bottom by 3, let me just put it down right here. 3 times this, 3 times that, this and that cancel, this and that cancel, we get that, right? So this is equal to 1 minus 1 over 3 to the nth power over 2. Okay, this right here only works for geometric, right? So just like that. Now, second part of the question, does Sn converge? Let's just go ahead and take the limit. So we will just have to check the limit as n goes to infinity of Sn. And this right here means we have to check the limit as n goes to infinity of that guy, well, this guy, same thing, right? 1 minus 1 over 3 raised to the nth power and then over 2. Take a look. Because 1/3 is less than 1, when you have this to the infinity's power, this is just going to be 0. So we just have 1 over 2. So the answer is just 1 over 2. So this case right here, I'll just tell you guys yes. And we know Sn converges to 1 over 2. And then with that, we are done. Okay, for number 4 right here, we see that we have the first term is just 1/2. And then every time, we multiply by negative 1/2 to get to the next term. So this is still geometric, but the common ratio is negative 1 over 2. How would you write a formula for this? We can use the thing that I told you guys in class. Put down the first term, which is 1 over 2, times the common ratio, which is negative 1 over 2, and you take that raised to the n minus 1 power. And of course, you can work this out a little bit. You can see that this is just equal to 1 over 2, and then multiply by negative 1 raised to the n minus 1 power, and then divided by 2 to that power. This times that, this is like 2 to the first power, then you can just add the exponents, so you get negative 1 to the n minus 1 power over 2 to the n. Yeah, so if you would like, you can also just write this down, but this is totally okay. Because this is geometric, let's use the formula I showed you guys earlier. So right here, I will just tell you Sn. Again, this is just because this is geometric. All we have to do is A1 times 1 minus r raised to the nth power, and then divided by 1 minus r. And just plug in. Of course, you should be able to do the nth partial sum the traditional way, but let's just use this. A1 is 1/2, and then multiply by 1 minus, r is negative 1 over 2, and then we have that raised to the nth power, and then divided by 1 minus r, which is negative 1/2. Okay, so this is 1 over 2 times 1. You have to keep this, so we have minus negative 1 over 2 to the nth power, and all divided by, this is going to be 3 over 2. And then we can just get rid of the 2 by multiply this and that by 2, right? Okay, so we have this over 3. So the Sn formula is just 1 minus parentheses negative 1 over 2 raised to the nth power all divided by 3. Yeah, pretty nice. Okay, question. Does Sn converge? In fact, because the common ratio has the absolute value less than 1, so we know this right here will work. It converges. And we can just take the limit for that, right? So let's go ahead and check the limit. We check the limit as n goes to infinity of Sn. And this right here is the same as saying, take the limit as n goes to infinity of that, which is 1 minus parentheses negative 1 over 2 to the n over 3. As n goes to infinity, because this is, the absolute value of this is less than 1. So this guy will just go to 0, so we just have 1 over 3. Yeah, very similar to what we did earlier. So in fact here we'll just say yes, and we know Sn converges to 1 over 3. That's number 5, and notice that 3 is the same as 1 times 3, 8 is the same as 2 times 4, 15 is the same as 3 times 5, 24 is the same as 4 times 6, and then this right here, 5 times 7. So the An formula is just 1 over n times n plus 2. So if you add them up, in fact we end up with a telescoping series. Have a look right here. I'm just going to start with Sn already because this is another special case. If you do it the traditional way, like S1, S2, and so on, so on, so on, it's going to be pretty hard to find out the pattern for that. So do it this way. Sn, which is just going to be the sum of all this, namely 1 over 3 plus 1 over 8 plus dot 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 up to this guy, 1 over n times n plus 2. And first, let's put this into the summation form. So we are going to have the sum. And because this is only the finite version, we want to end up with n, so I will have to have the n right here. That means we should just use another index right here. Let's say we have I goes from 1 to n. And then right here we can just replace the formula. Instead of the n, use I. So we have 1 over I times I plus 2. And you see, this right here means you plug in 1 into I, so you get that. And then you plug in 2 into I, you get that, and so on, so on, so on. Lastly, you put down n into I, and you get that. Okay, to take care of this, let's do partial fractions. So let's still write down this. The sum as I goes from 1 to n. We will have some number over I plus some other number over I plus 2. To figure this out, we go back to the original and cover the same denominator, and we have to make I equal to 0 by putting here. 1 over 0 plus 2, we get 1/2, so that will be right here. Next, to figure this out, we go back to the original, cover this up. I has to be negative 2. Put it here, so we get negative 1 over 2. And now we see both of them have 1/2, so we can factor that out. So this right here is just 1 over 2. And then again, we have the sum as I goes from 1 to n. And then we just have 1 over I minus 1 over I plus 2. And let's go ahead and do this the quick way. Okay? Seriously, the quick way. So this is how you do this the quick way. 1 over 2 all the way in the front, no problem on that. First, you see that I and I plus 2, they differ by 2. So this is what you do. Starting with the first part right here, putting 1, putting 2, and you have 2 terms, because again, they are off by 2. If they are off by 17, you do 1, 2, 3, 4, up to 17, you have 17 terms. But again, they are off by 2, so we just have 1 over 1 plus 1 over 2. So that will be in the beginning, all right? Next, put this down at the end, which is negative 1 over, but you have to plug in n, because that's the last term right here, right? So we have n plus 2. But we also need to have another term in the front, and that will be, you're putting n minus 1 in here. N minus 1 plus 2 is n plus 2, right? Plus 1. Yeah, so this right here is actually the formula for Sn. Why is this? Well, let me show you guys the long way right now. First, we have the 1/2 all the way in the front. And then, let's just expand it. We are going to put in 1 into the i's. So, this is the first term. We get 1 over 1 minus 1 over 3. So, right, this right here is the first term. Next, we have to put I is equal to 2 in here and here. So, we get 1 over 2 minus 1 over 4. Next, we have to put I is equal to 3. So we get 1 over 3 minus 1 over 5. So far so good. And it keeps on going, right? It keeps on going. Up to when I is equal to n minus 1, you just put it here and put it here. So we have 1 over n minus 1. And then you subtract 1 over n plus 1. Because when you put this right here, you get that. Lastly, I is equal to n, and you will just get 1 over I minus 1. So you will get 1 over n minus 1 over n plus 2. And that will be the last term. Now check this out. 1 survives because there's nothing else that we can cancel. But negative 1/3, this right here will cancel with that. 1/2 survive because there's nothing like negative 1/2. No. But this right here is negative 1/4. This right here will cancel with the next term when I is equal to 4. So they cancel. So this right here cancels with that. This right here is gone already. This guy is going to be cancelled with the next one. We just didn't write it down. So on, so on, so on. In fact, if you pay attention earlier, look at this parentheses. It got cancelled because we have this in the front. And we skip 1, right? And the reason is because they differ by 2. So if you look at this right here, this is going to get cancelled from something else in the front. And then if you look at this, this is going to be cancelled with something else in the front. And that's it. That will be the remaining part. So you have the 1/2, and then 1 over 1, plus 1 over 2, and then minus this, minus that. That's the idea. So I'm just going to leave it right here for the Sn formula. I'm not going to simplify it. Just work out the fractions on your own. Now let's look at the second part. Second part, question. Does Sn converge? Again, for this right here, we'll just have to check the limit. We check the limit as n goes to infinity of Sn, which is just that. So let me just write that down this time. 1/2 of, let's add them up. We get 3 over 2, and then minus 1 over n plus 1. And then minus 1 over n plus 2. Well, to do a limit right here, you see that this is going to approach 0, likewise that. So in fact, we just have this and that. So we get 3 over 4. Does Sn converge? Yes, it does. And we can say Sn converges to 3 over 4. Alright. Hopefully this video helps. If you guys need more help, check out my other videos and subscribe to the channel for future videos. That's it.